Okay, the first part of the assignment you're going to do today is more reflections. But you're not going to just do reflections across the x or y axis. And the key to this first part with reflections is knowing what the line is that you're reflecting across. And I think once you can draw that line in, you're not going to have any trouble doing the reflections. So here's what you're going to see. You're going to see 4 different possibilities. One is x equals something. Another one is y equals something. And then you'll see y equals x or y equals negative x. Okay? These two obviously are always the same. These two will shift, left and right where they are. So the question is, like you can see here in this first problem, and this is not the same one from your assignment, it's just an example. So the first one, it says x equals negative 2. All right, well, where is that line? Well, let's try to find all the places where the x value is negative 2. Well, certainly it's right here, right? And the coordinates of that point is negative 2, 0. Well, where's another point where the x value is negative 2? Maybe right here. That's negative 2, 1. Negative 2, 3. Negative 2, 4. Sorry, negative 2, 1. Negative 2, 2. Negative 2, 3. Negative 2, 4. So on and so forth. And you can see that those all line up. The x value at all those points equals negative 2. So there's the line x equals negative 2. Once I have the line drawn in, now I just reflect it like it was across the x or y axis. G is going to reflect over to here. A is 2 away from the line, so it's going to reflect 2 to the other side. And T is 2 away that way, so it's going to reflect over here. And notice when I'm all done, you can see if I fold it along that line, all the points would match up. Okay? Another example you might get is where y equals something, and number 3 on my examples here has that. So where y equals 1. Okay, well, where does y equal 1? Well, we know it equals 1 right there, but it also equals 1 at all these points. This is 1, 1, 2, 1, 3, 1. Those are all the points where y is 1. So this would be the line y equals 1. Okay, and once I have that line drawn in, again, I just reflect over. D's not going anywhere. M, 1, 2, 3, 4, is going up to here. And Z is going right to there. Okay? All right. 4, very much like number 1. Now, if you're asking a question right now, or you might be asking a question right now that's really common, and that's this one. Why the heck does y equals 1 run this way when the y-axis runs this way? And that's a really good question, and it's a place where a lot of people get confused. Here's the thing. The y-axis actually is the line x equals 0. Everywhere on the y-axis, x equals 0. And the x-axis actually is the line y equals 0. We just call them the x and the y-axis because they're what we use as the reference points to see what the x and the y value are. Okay, so don't get confused by that. X lines, lines that are x equals something, those run straight up and down. Lines that are y equals something, those go left and right. Okay, now, the other ones that you will see are ones where we're reflecting against y equals x. And I don't have any examples on this sheet, but I can do one very easily. Okay, let's pretend that this one right here said, instead of that, it said y equals x. Well, where's all the points where the x value and the y value are the same? And one of them is really easy to see. 0, 0, 1, 1, 2, 2, 3, 3, negative 1, negative 1, negative 2, negative 2. See how all those points line up? That then is the line y equals x. All right, now I have to reflect across that. Here's where this one becomes tricky. You can't count z as being 1, 2, 3, 4, 5 units away from the line and then try to reflect it 5 over. Because remember, reflections happen perpendicularly across the line that you're reflecting across. So what you're going to want to do is turn your paper diagonally so that you can see the line straight up and down, and it's easier to visualize moving it across. Now, the other weird thing is when you count the distance away, you're going to want to count by diagonals. So it's 1, 2, and a half diagonals away. So there's a half, and then 1, 2 more. So that's where point Z went to. All right, J is 1, 2, 3 and a half. There's a half. 1, 2, 3. There's J prime. B is 1, 2, 3, 4 away. 1, 2, 3, 4 away. And then Q, 1, 2 and a half. There's my half, and then 1, 2. Okay, and there's a reflection over the line y equals x. Okay, we can also reflect over the line y equals negative x. This would be a good one to do. All right, y equals negative x. Well, all that means is it's all the points where the y and the x have an opposite value. If one's positive, the other one's negative, but the same value. So 2, -2, or 3, -3. So like 1, -1 is right there. -1, 1 is right there. 2, -2, -2, 2. And you can see those line up. It's just the other diagonal. Right? And then these lines should also make sense from the standpoint of, if you remember y equals mx plus b, the slope of this line is 1. Right? Up 1 over 1, up 1 over 1, and it has an intercept of 0. The slope of this line is -1, and it has a slope of 0. Down 1 over 1, down 1 over 1. Okay? From there, the reflection is the same. All right, so to reflect, I just make sure I count diagonally. So P is 1 1/2 away, so I go 1 1/2 to the other side. E, also 1 1/2. J, or I. And then Z, 1, 2, 3 1/2. A half, 1, 2, 3. Z. All right, reflection. Okay, so the hard part of this is just making sure that you've got the right line to reflect across. Once you do the reflection part, actually is not that difficult to do. Okay, now I'm going to talk about rotation. All right. Rotation is different. So when a figure rotates, it needs to rotate around a point. And all the points that you're going to do today are around the origin. Okay? And the best way to visualize a rotation is with some scratch paper. So I'm going to take some scratch paper here, and I'm going to use it to do this rotation. And then I'm going to show you a couple other ways that you have an option to do it also. Okay, so what my figure needs to do is rotate or spin 180 degrees about the origin. So the origin is the place that's going to stay the same. Okay, I'm going to draw my axes on here just so I have them kind of as reference. Okay. All right, and I think it was JKL. JIT. That makes a lot of sense. JIT. Okay, so now that's all lined up on there. Okay, it's going to spin around the origin 180 degrees. So what I need to do is spin my scratch paper 180 degrees. So there's 90 degrees. There's 180 degrees. Right there. All right, now I can kind of see where my figure needs to be. And if I want to, I can just sort of look at what the coordinates are. So T is at 1, 0. And then I can go here. That's where T prime is going to be. I is at 5, 3. And then J is at 3, -1. 4, negative 1. 1, 2, no. Hold on. 4. Sorry, I is at 4. The grids on my scratch paper and the grids on the thing don't match up. J is over 1, 2, 3, 4 down 1. Okay. Okay. And there's a 180 degree rotation. Now, if the rotation is 180 degrees, we don't have to say clockwise or counterclockwise. Okay? I drew that to the wrong place. Dang it. Sorry. Okay, that's better. We don't have to say clockwise or counterclockwise if it's 180 degrees because it doesn't matter. Right? Clockwise or counterclockwise, 180 degrees gets you in the same place. Alright? Clockwise or counterclockwise, though, you just turn the same way a clock does. Okay, so if it's counterclockwise, what that means is that this shape is going to twist this way. Okay, spinning this way. Clockwise, spinning this way. Okay, now I'm going to show you another way to do this where you don't have to use scratch paper. What you can do instead is just turn your paper, and then you'll see where it's at and find those coordinates. So here's what I mean. So this is going to turn counterclockwise. So counterclockwise means spinning this way. Okay? If I just turn my paper 90 degrees counterclockwise, it looks like this. So when I'm all done, turn back correctly, this is what I need my shape to look at. Like, U is at 1, 1. Okay? So if I go back to regular, and I go to 1, 1, there's U. U primed. Okay? If I go back, Y is at 1, negative 4. So there's where Y prime will be. Okay? P is at 2, negative 3. So 2, negative 3, right there. Okay? N will be at 3, negative 3. Prime, prime, prime. Alright. And then I just connect. Okay? Either of those ways, I think, are fine. I think personally that it's easier to visualize if you turn your paper and you're not worried about like drawing a scratch paper on there. You saw what happened with me where the grids on my scratch paper aren't the same size as the grids on the paper, so I started counting off. So I think it's easier just to turn your paper. So likewise for this one, if I turn it 90 degrees, clockwise, it looks like this. Okay, so what that means is I need my whole figure to be in quadrant 1. And then F is at 2, 1, W is at 4, 1. So 2, 1, F, 4, 1, W. Prime, prime. Okay. Z is at 1, 2. S is at 5, 4. Connect my points, and I'm done. Okay? Now the only rotations you're going to worry about today are all around the origin. Obviously you could turn from any point, right? We could, instead of here rotating around the origin, we could rotate it 180 degrees around point E. Now that's going to be harder to do. We can't just turn our paper and count the points because it's going to turn, if I do this with scratch paper, right, if I turn it around point E, notice, right, there's a 180 degree turn. It's going to be up over here. So it's going to be kind of up in this area. Something like that. Okay? So we'll work on that later though. Everything today is around the origin. Alright, so you have, excuse me, so you have reflections number 2 and rotation number 1 to work on today. And I will see you guys on Wednesday.